Hello, and let's look at our first chapter, Chapter 1. We're going to look at Section 1 today. So, Section 1 looks at chemistry as a physical science. 3 objectives we will be covering in this video. The first one is to define chemistry. Then we are going to list examples of the branches of chemistry, and we are going to end today with comparing and contrasting basic, applied, and technological development. So, what is chemistry? It is the study of composition, structure, properties, and the changes it undergoes. So, as we look at that, pretty straightforward, but what do each of those pieces mean? Well, composition. Composition is what something is made of. So if we look at the water molecule is made up of some hydrogen atoms and oxygen atoms. Carbon dioxide, carbon atoms, oxygen atoms, or even methane, some carbon and some hydrogen. That is the composition, but what is the structure? Structure is how they are bonded, what type of bonds, what kind of structure, what 3D shape does it take. Water is our Mickey Mouse. We know we have oxygen with its 2 hydrogen ears, and then you'll find out that there are some extra dots hanging out. Those dots are going to be known as electrons. You'll figure this out later on as we go. Carbon dioxide. Let's make this an oxygen. And that becomes our carbon dioxide. You can see very different shape, even though it also only has 2 atoms that are being bonded. Or 2 different atoms, 3 total. And then we have our methane, which is going to look quite different than the other 2. But again, it looks like it's got some dots around it. And then we look at the properties. Well, what properties do we know of water? Well, water is usually a liquid, at room temperature at least. Maybe we have it as a gas. We know that it's got a high boiling point. We know that it's got a density of 1. Carbon dioxide, gas. It's got a low boiling point because it's a gas at room temperature. And then methane. What do we know about methane? Maybe we'll find out. And then, of course, changes it undergoes. So, what is chemistry? Well, chemistry is the study of composition, structure, properties, and the changes it undergoes. So as we look at different compounds, we're going to look at each of these things, not all at the same time, but as you go throughout this year, we are going to cover each of them. So composition. Composition is basically what is a compound made of. So if we look at water, we know water contains some hydrogen, some oxygen. We have 2 hydrogens. So, what is chemistry? Well, chemistry is the study of composition, structure, properties, and the changes it undergoes. So we're all kind of familiar with those words, but what does it mean when we look at chemistry? Well, when we look at composition, we're going to look at what is actually a molecule made of? What atoms go together to make this molecule? For example, you guys all know water. So, what is chemistry? Well, chemistry is the study of composition, structure, properties, and the changes it undergoes. So, if we look at composition, what do we mean by composition? Well, basically, what is in a molecule? So, for example, water. We know water has 2 hydrogen atoms and 1 oxygen atom. What about carbon dioxide? It has a carbon and it has 2 oxygens. And then we have methane. Methane has a carbon and 3 hydrogens. All of them contain just 2 different types of elements, but different ratio of amounts. So we move on to structure. Well, each of these, because of the different ratios of its elements and the types of elements that are bonding, will have different structures. So water, we know water has oxygen with 2 hydrogens, our Mickey Mouse. And then we have carbon dioxide. Very different structure from hydrogen. Lot more dots we see. It's got more straight across than any bends. Why we have a structure like this, we will get into at a later chapter. And then methane, again, also has its own unique structure compared to the others. And we'll get something that looks like that. So properties, basically what you know about the compounds. For example, we know that water is a liquid. We know it has a density 1 gram per milliliter. It's got a higher boiling point, which is about 100 degrees Celsius. Carbon dioxide is a gas already at room temperature, so maybe it has a lower boiling point. It is not flammable. It actually is used to put out flames. Why a lot of your, I don't know. And then methane. Methane we know is flammable. So you can see lots of different properties about the structures that we have here, but all considered properties. And how we get those properties and why they have these properties is based on the structure due to its composition. And finally, what changes do they undergo? So let's take some methane and react it with some oxygen. You do that, and we get some exciting kaboom happening. So yes, this would explode, and we're going to get carbon dioxide and water. Now from here, there's more that we would do to this equation. For example, look, I've got 3 hydrogens here, I've only got 2 hydrogens here. That will come later. But for the time being, you can see that carbon dioxide or methane reacting with oxygen gives us some different types of compounds. So let's look at number 2. What are some branches of chemistry? First one is organic chemistry. When When we look at organic chemistry, we're going to look at it being the study of most carbon-containing compounds. Carbon being our key word here. When you look at many organic compounds, you're going to see lots and lots of carbons, as in caffeine that's listed here. So that cup of joe that you have in the morning contains lots and lots of carbon, and it is considered an organic compound. Inorganic chemistry is the study of all substances not classified as organic. Hence we have inorganic, which means it is not organic. So those are all of the other compounds that don't fall under the tense of having lots of carbons. Physical chemistry, study of properties and the changes of matter in their relationship to energy. So we're going to be looking at adding, subtracting energy, energy changes. For example, if we're going to fry an egg, we need to add lots of energy. If we're going to melt the ice, we're going to need some energy, but we don't need as much as if we were going to fry the egg. In biochemistry, we have the study of substances and processes occurring in living things. In living things, we have you, me. What's inside of us? We've got DNA. Ooh, this nice little structure here. Well, as you can see, it's not just a bunch of letters put together, but it is a bunch of elements. Put them together, they come together in a crazy chain. They make up all of your DNA. And we have analytical chemistry. So this is your identification of components and composition of materials. So how do we know that hydrogen is made up of, or that water is made up of hydrogen and oxygen? I don't know. Somebody did some analytical chemistry on this substance some time ago and found out, hey, look, there's some hydrogen and there's some oxygen. So it's identification. What is this unknown substance? And finally, we have theoretical chemistry. This is where you get into the math, and we use computers to understand principles behind observed chemical behavior. So we want to see how things happen over and over and over again. We use a computer so we can see these trends, and they will map it out for us. And we can then design and predict properties of new compounds based on what we know of known compounds. Hey, if we get a new compound, we can test it analytically to find out what's in it, and then predict by the math that we already have set in place. And section, or I should say objective number 3, types of research. So basic, we're just going to increase our knowledge. So we have Mr. Caveman here talking to Mrs. Caveman, and all he said was he was rubbing some sticks together. He was increasing knowledge. What happens when I rub 2 sticks together? Well, guess what? He got fire. In applied research, we want to solve a problem. So now we have the caveman. He starts saying, hey, you know, it gets kind of cold out here at night. Or, you know, I just killed this mammoth. I have all this meat. What do I do with it? Well, hey, we know if we rub 2 sticks together, we get fire. How can the fire help us? We can use it to, hey, warm ourselves. Maybe if we put it in our cave, it'll help warm the cave. We can use it to cook our meat, make it healthier. And finally, we have technological development. So the production and use of products that increase our quality of life. Well, now that we are fed and we have heat, we can build on that. What happens if we start cutting away at some stone? Make this stone round instead of square. What happens? Well, we get the wheel. The wheel helps us improve our way of life. So now we can get around easier. So technological development, production, and use of products that increase our quality of life. And that's it. I hope you have enjoyed your first video of the year.